Moving on now to the synthesis of amides, I'm going to look at amidation, and this is going to be a acid catalyzed type process. And here is the pattern for that again. We're using the same pattern. The Y ends up being replaced with an X group, the Y being the OH in this case. Let's see how that works. Right, so there's our Y group. It's going to end up being replaced. Now the X group, I'll make this, I'll draw this out a little bit more clearly so we can clarify our X group, because it's going to be XH and it's going to be everything here minus one of the hydrogens, not both hydrogens, just one of them. And you can see that this will be the X, and then the X group ends up being attached where the Y was. There's the X, and here's our YH, which is HOH or H2O. Now let's take a look at the mechanism, and you'll see it follows the same. You'll see it follows the same pattern as before. So the first step is the addition of the H plus to the C double bond O. Next, the nucleophile comes in. That's going to be the X group, and it's always the atom that is attached to the hydrogen. That's the one that ends up attacking. There we go, and attacks the C plus. And that leaves a positive charge on nitrogen. And then in the next step we're going to get the proton transferred, and as I said in the past, the proton will always be transferred to the leaving group. The leaving group is the Y group, which was the group originally attached to the C double bond O, which is the OH. So the OH will take the proton in that step. And then what will happen is that the leaving group will leave. I'll draw this bond out here a little bit more. Then we'll reform the C double bond O and kick out the leaving group. And there's our product, which is an amide. Alright, so it follows pretty much the same patterns as we've been looking into. Alright, and there you go.